In this section, which is 7C, we will look at the double angle formulae. So these are not given in your formula booklet. However, they can be derived. They can be derived from the addition rules. Let me just show you quickly here at the bottom. So if you remember the sign addition rule, which was sine of A plus B equals sine A cos B plus sine B cos A, or you could write that the other way around. That's just the way I always write it. If we set A and B equal to each other, so if we say A equals B, well, that will give us sine of 2A, won't it? And what would it do down here? It would give us, well, all of the B's we could write as A's because they're the same. So it would give us this, sine A cos A plus sine A cos A. In other words, you get the same thing twice. So we have two lots of this thing here. Okay, that's called the double angle formula for sine. Okay, so sine of 2A equals this. Again, it's not given to you in the formula booklet. It's an identity that connects sine of an angle, and it also connects it with sine of half of that angle, with cos of half of that angle as well. Some other things to notice. So as well as this value here being doubled, so for example, if A were 10, so if this were 2 sine 10 cos 10, that would be equal to sine of 2 times 10, 20. So we notice the 10, 10, 20. We notice the doubling there. That's why it's called a double angle formula. But also this number at the front is halved, okay? And sometimes the question looks like this. Sometimes it's a little bit harder to see. So sometimes you get given a question like this. You have 8 sine, let's say 15, cos 15. And we're meant to be able to recognize that that could be written as, well, halve the number at the front, which was a 4, and then sine of twice of that. Okay. In fact, we know what sine 30 is, don't we? It's a half. So that's 2. All of this is equal to 2, and you can show that by using a double angle formula. And yes, you do need to be able to go backwards, so you need to know these very, very, very well indeed. Okay, cos. So the same thing happens with cos. You know, we could go through the sort of, we could derive it again if you wanted to. If you remember, it's cos. So you know, like cos A cos B minus sine A sine B. Well, that's the cos addition rule. If I put the A's and the B's equal to each other, you could see that I will get this result here. Okay. So this is the cos double angle rule, which is very useful indeed. We normally write it in this form or this form here. So instead of talking about cos and sine, cos squared minus sine squared together, tends to be more useful to only have cos squared in it or only have sine squared in it. The way you do this, if you forget at any point, is you use sine squared plus cos squared equals 1. You use that one in there. So for example, if I substituted out the sine squared, well, remember sine squared is equal to 1 minus cos squared. So you would get cos squared minus 1 minus cos squared. And you end up with a double negative on cos squared, which gives you 2 cos squared, and you end up with the minus 1. Okay, try it for yourself. I encourage you to pause the video, start with cos squared minus sine squared, and just check that you can get both of these results here. Okay, you are allowed to use them as given though. You want to memorize these really, because they're not given in the formula book, and they are hugely useful. They're a tool that you will use a lot. So sine and cos double angle. There's also tan as well. Tan tends to not get used quite as much, but it's got the same trick. Set the A's and the B's equal. Look at the formula booklet, the addition if you forget, and you can quickly get that. Again, though, you do want to get to the point where you remember it, because especially for sine and cos, you will be using these an awful lot. Okay. So use the double angle formula to write each of these as a single trig ratio. So what we want to do is we want to only see sine or cos or tan. We don't want cos and sine. That's what that instruction means. Well, I recognize cos squared minus sine squared as this one here. So going backwards, that must be the same as cos 2x. Well, what's in the x position? It's 50. So 2 times 50, it must be cos 100. Okay, that's what I'm looking for this one. Let's just reveal that box. I'm not sure why that's not doing that. Okay, so we've got that result there. The same one. So another reason why you need to know it is about pattern spotting. So 2 tan 1 minus. I recognize it as the tan double angle. What's in the position of x? Well, it's the pi over 6 thing. Okay, so 2x must be pi over 3. In other words, that whole thing there is tan of pi over 3. Okay. Here we're not working it out. We're just rewriting it as a single trig ratio. And the last one is a bit deceptive. So when you have like sines and sec, or sine and cosec, or something mixed together, it's a good idea to try to remove the reciprocal part. So if you wrote that as 4 sine 70 times 1 over sec 70, that would be a good start. Sec is cos, but upside down. So this must all be the same as 4 sine 70 cos, third letter C, cos 70. Well, now that looks like sine double angle, doesn't it? This is in the position of x. So 2x will be 140. There's not a 2 at the front, though. There's a 4. So I need to double everything. Sine 1 sine 2x equals 2 sine x cos x. So 2 sine 2x equals 4 sine x cos x. Okay, so my final answer then is 2 sine 140. What's been done there? The sec part, they don't tend to do that so much. But having a 4 at the front instead of a 2, having a 4 or a 6 or an 8 or something like that is quite a common thing that you'll be asked to do. We're going to leave that one, I think, for chapter 8. Let's have a quick look. Shall we leave that one for chapter 8? Given that x equals sine theta and y equals 3 minus 4 cos. Well, let's just talk about it a little bit. Eliminate theta. Now, that's really talked about last chapter, okay? Because they have an x and a y, but they also have a theta here. So sometimes you have 3 things. It's called parametric equations. It's the next chapter. But I think why this one's in here is they want to just show you this idea again. Look, sine theta and 2 theta. So we would do some work on this equation that has 2 theta, and hopefully that sort of helps us out. So y equals 3 minus 4. Now, that cos 2 theta, I have a choice. I could do this, or this, or this. And I'm going to pick the one about sine. And the reason for that is this one is about sine as well. So if I write 1 minus 2 sine squared theta, look what I can do. So y equals 3 minus, well, let's expand that out. That's 4, okay? And then again, double negative, that will be 8 sine squared theta, okay? 3 minus 4, well, that's just, that's minus 1. And this question wants you to get rid of theta. Well, the way you can do that is you can use the other equation. Divide by 3 on both sides gives you x over 3 equals sine theta. Well, if you square it, you'll get x squared over 9, which must equal sine squared theta. And the idea, again, it will be talked about a lot in the next chapter, is sometimes we can use 2 equations like this to eliminate something. So the sine squared here, I could actually remove it. So minus 1 plus 8, and sine squared is the same as x squared over 9. So this is more of a preview than anything else. They're showing you that later this is a tool to remove things. For example, to make an equation that only has y's, x's, and constants in it and doesn't have theta. More immediately, let's have a look at this one here. So cos x equals 3/4, and it is acute. Find the exact value of sine 2x. Good place to start is to notice that they don't match. So sine 2x, there's only one rule for that. So just use that rule straight away. 2 sine x cos x. Yeah. Cos x is 3 over 4. So that there is 3 over 4. Sin x, how do we find sin x? Is what we talked about, isn't it, previously? So draw a sine graph. You know that sine is acute because x says x is acute. So x is acute, yeah. So you know we're talking about a positive value there. And the way we work this one out, we know that sine squared plus cos squared equals 1. Cos squared, well, we know cos is 3 over 4, so we could fill this in like so. Sine squared plus, that's going to be 9 over 16 equals 1. You could rewrite 1 as 16 over 16. That's just one way that you can do this question. So sine squared must equal 7 over 16. So it must equal, sine of x must equal plus or minus root 7 over 4. And because I know that it's acute, that lets me know that it's actually the positive only. Okay, so root 7 over 4. So they're just showing us again that you know, we can break down, we can sort of break things down if we have double angle, a bit like when we had addition rule. Okay, we can use pieces that have cos x, even when the question is about sine 2x or tan 2x. Yeah. For tan, you know, for tan you can do the same sort of thing. So tan 2x, we'll use this one here. But where does tan come from? Where do you get that piece from? That piece of the puzzle? Well, tan x is the same as sine x over cos x, isn't it? So you can use the pieces here earlier in the question to find that and to put that result in. Let's just show you that, a neater version of that. Okay, so that's the one that we did there together. You find out what tan of x is for part B, and then you use that, you know, with this one here. A couple quick examples. Pause the video and have a go at those ones there on the screen. So those results there, those ones are quite nice ones. I hope you read the hint here to help you out. So when they ask you about sec of 2x, it's a good idea to go down this path, okay? Because then you will be able to use cos double angle. Remember, when you have cos double angle, you always have a choice. So do you want the one with cos and sine? Only cos or only sine? Well, given that sine has been given to us in the question, it makes sense to use the one with sine. Okay, so you can use this 3/5 result over here. Okay, one more tip I would say is, in this situation, I would be inclined to write my sine squared x like this. Okay, it's easier to do your substitution then, isn't it? So you do 1 minus 2 3/5 squared. That way it's quite hard for you to make a mistake. Okay, it should be 25 over 7. And that takes you to 7C. So make sure that you spend a little bit of time doing a bit of memorization here, because you're going to use these very, very heavily, especially sine and cos. I recommend starting with the formula booklet, the addition rules, set A and B equal to each other, and you should be able to derive all of those results. However, you want to be in the position that you can state them quickly. Okay. What I always do is I remember this one in my head, and then I remember that if it's cos, cos is at the start. If it's sine, sine is at the end. Okay. That should take you up to 7C.